Hi there, we are Group 3. We're working on the American Sign Language Motion to Text Projection project. This is our showcase presentation. We'll do a quick PowerPoint of our overview of our project and then a quick demonstration of how our project works. In our group, we have Keone Adams, Lance Congolo, Olamjede Coyote, and Miguel Cordero. Quick overview of our project. The goal of our project was to design a portable educational device to teach ASL anywhere to large and small audiences. We hope to create awareness for the deaf community and encourage more people, especially students, to learn American Sign Language. We accomplished this by creating a glove to capture ASL gestures by creating data, the machine learning software which was translate the glove data into actual predicted letters, and a light projection to display visible output. Key components, we had the glove affixed with a group designed printed circuit board, flex sensors, force sensors, accelerometer, and gyroscope to capture data, and a Bluetooth module to transmit that data wirelessly to the PC. We use a projector fixed with beam splitters, LED light source, design lenses, and mirrors for reflection. And as far as software, we use Python for machine learning and support vector machine algorithms specifically for our machine learning. Python Flask for our web application to be able to see it working all together. And C to program the electrical components. As for collaboration, we met at UCF, weekly meetings at the UCF Physical Science Building. We just had a good space there where there wasn't many foot traffic. We had reliable internet. It was a middle place for everybody to meet. It was helpful for those of us who had other classes to attend before and after. And we had the resources nearby, the Senior Design Lab and other UCF resources available. Outside of UCF, we communicated via Discord. It was easy to communicate. We posted links, pictures. We even had voice calls after we had meetings with a professor via Discord. As for testing and implementation, all our prototyping, especially for the glove, was done on a breadboard. We just set up the whole circuitry there, and once we were happy with it, we started moving on to actually creating the printed circuit board. We tested every component individually and then together for both the glove component and the projector component. This way we knew everything was working, and then we had to make it all work together. Projector component were also tested individually. This would be the light source, lenses and mirrors, and LCD panels, and once they were all found to be working, we put them all together to make sure they were doing what they were supposed to. We had a few challenges, but we also had some motivation. Supply chain was a large problem. It was hard to get a lot of components, or a lot of things were out of stock, and we had to design the circuit boards not around what was ideal, but what was available for a lot of things. And we also had to make sure we ordered enough of everything early. That way, if we ever needed something, we didn't have to worry if we was going to get here on time. We planned on using a certain LCD that's commonly used in projectors, but we were not able to find the documentation or pinout for that. So we had to use basically an LCD that had a backlight, try to remove or hide the backlight. It was bigger than we wanted it to be. So it made the projector a little different than we wanted to, but we had to work with what we could. First PCB was having issues. We couldn't figure it out. We thought it was a pinout. Later on, we found out that it was something to do with the resistor values being too large. But we did stay motivated. We did so by having the drive to graduate. We had the drive to make a deliverable and presentable project. We worked together to find out all possible solutions, and we just honestly never gave up. We kept communication with professors open. We took their feedback very seriously, and we took it as a learning experience. And we also reached out whenever we encountered large issues. So the overall experience of our project, we truly enjoyed the experience of senior design. Main lesson would be teamwork, especially on an engineering project, and the importance of managing time and expectations. We did learn how to listen to our superiors and how to take their advice, because our initial project pitch was completely different than this. And our professor told us that we had to make it a little better, and we did, and we were happy with our project. And we kind of would have loved to add more sensors and more data. That way we can create a more accurate ASL projecting device to teach a larger range of the language. But yeah, that's it. We will now demonstrate the video, which shows all our how our project works. And if afterwards you have any questions, feel free to email us or just reach out to our professors. Thank you. All right, we're group 3, and we're going to do a quick demo of our project. This is the ASL motion to text projection. This is the glove that we have designed with various sensors in our design PCB. And over here you will see our output. So whenever we make a prediction, we'll get the data value showing that was being created by the glove and being received, and then what it's predicting. So if I was to make a letter right now, if I was to make, let's change it up, that, this one. So I made a C, as you can see in the reflection in the screen, and also here we got a C. We're using machine learning. It's still not 100%, but we do get a good amount of letters. I did a B right now, and I'm hoping that it does predict a B, and that is correct. And this is just to show the data, but we do have a light projector, which we're going to show right now. So we'll turn off the lights real quick. And
here we have the projector that's actively displaying the predictions of the sign language that's shown from the computer over there. All right, so here we are having issues with the LCD being really finicky with the backlight. We wanted to remove it, but it needs to be attached for it to work properly. So we're just kind of just leaving it like this just for now. We're gonna see if we can get a better display later on. But here we have the LCD that's disattached from the backlight, and we have our own LED that's shining in the back of it. Right around here is where that that letter is showing from the computer screen. And inside the projector is going to be a negative lens that's going to create a virtual image that then the positive lens right after is going to be projecting that virtual image from behind it. And that image will then be collimated, and it's going to hit a mirror at the bottom that is angled 45 degrees, and it'll travel upward into this concave lens that has a focal length of 30 centimeters. And we picked a concave lens just because it is able to project an image without any aberrations like lenses would usually cause.